National 5 Maths 2017, Paper 1, Question 1. F of x is x squared plus 3x. Calculate f of minus 5. So it's substitution. F of minus 5 equals, be careful now, it's minus 5 squared plus 3 times minus 5. Minus 5 squared is 25. Minus times a minus is a plus. 3 times minus 5 is minus 15. 25 take away 15 is 10, and we're done there.
Okay. Interquartile range, SQ National 5 Maths 2017, Paper 1, Question 2. Just before I go into this, just be aware that past paper questions will often say semi-interquartile range for National 5, because it used to be that, but it changed recently to interquartile range. So I'm going to work out the interquartile range, even if it says semi-interquartile range, but then give you the final answer for semi as well, which just means half of interquartile range anyway. Let's get straight into it. The number of calls received by police was recorded over 10 days. The results are shown. Find the semi-interquartile range of this data. First thing we need to check is the data needs to be in order from smallest to biggest. So a little quick check, smallest all the way up to biggest. So we're happy there. And then for interquartile range, we need the upper quartile and lower quartile. So we need to find the middle first. So let's find the median. So the middle, we count up how many there are to find where the middle is. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you then add 1, so you can almost say it's going to be about 5, but it's actually going to be 5.5 because I'll have 1, 2, 3, 4, 5, cut 1, 2, 3, 4, 5. So it's going to, the median is going to be here. So there's my median. And there's a number of ways to work these out, but basically you want the middle of these two numbers. One of the quickest ways to do it is add them up and divide by 2. So I'll do 232 plus 247. You can use a calculator for that if you want. 479, and then divide by 2. 479 divided by 2, 39.5. Now technically you don't actually need the median number for this question, but I always work it out anyway because you often need it for other questions. But now we need the middle of the upper and the middle of the lower. So the middle of these numbers is clearly here, so I'll just circle that. That's my upper quartile. And the middle of the lower numbers is here, so that's my lower quartile. So the interquartile range which is what you would be getting asked to do from this year onward, would be the upper quartile minus the lower quartile. So in other words, 250 minus 218, which is 32. But to answer the specific question, because it is a past paper question, it says for semi-interquartile range, so the semi-interquartile range is equal to 32 divided by 2, which is 16. But just remember, you'll be getting asked to do interquartile range, so just 32, don't have it. Okay, another interquartile range question, this time at SQA National 5 Maths 2019, Paper 1, Question 5 says, the midday temperatures in Grantford were recorded over a 9-day period, and they were here. Calculate the median and semi-interquartile range. So this one, we do have to calculate the median, and then we'll have to make 2 comments about that, which we'll get into when we get there. So remember, median and semi-interquartile range, we need the data to be in order. So let's start with that. I've already put in the data in order for us, and we need to find the middle of that. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 plus 1 is 10. The median happens at 5. 1, 2, 3, 4, 5. So there's my median right here. And I'll put the answer properly in a minute. Let's use a different colour pen. So the upper quartile is the middle of the upper half, which is 4 numbers, so it's in the middle here. So I'll draw a little line. There's my upper quartile. Well, the middle of 7 and 9, no work required there is 8. If you didn't need some work on that, you just do 9 plus 7 is 16 divided by 2. The lower quartile then is the middle of 3 and 4. Well, that's 3.5. Again, if you didn't know that, 3 plus 4 is 7, divided by 2 is 3.5. So we can write that out in nice and neatly. Upper quartile is equal to 8. Lower quartile is equal to 3.5. My median was equal to 5. And the question asked us for the semi-interquartile range. Now remember, in National 5 from now on, you'll get asked for the interquartile range, but I'll do the semi as well. So the interquartile range is just 8 take away 3.5, upper minus lower, It's 4.5, but to answer the questions for this paper, the semi-interquartile range is just half of that. So 4.5 divided by 2, which is 2.25. Let's move on to the comparison statements, which work the same way for interquartile range or for semi-interquartile range. Over the same 9 period, the midday temperatures in NDOC were also recorded, and the median was 8, and the semi-interquartile range was 1.5. Make 2 valid comments. So this is a bit like when you did standard form. Median is the same as mean, basically. You're using on average. But for interquartile range, that's the same as standard form. You're using consistency there. So let's start off with median and then consistency. So let's take a note of the numbers we need. So I'll just take a note of this one and go down below. Part B, on average. Our median in Grantford was 5, but in NDOC is 8. On average, the temperature in NDOC are higher, since 8 degrees C is bigger than 5 degrees C. The temperatures in NDOC are more consistent, since 1.5 is less than 2.25. So more consistent, smaller interquartile range, just like standard deviation. Moving on to line of best fit. This is basically a straight line question, but it comes in the stats topic because it uses real world data. So it is all just straight line with a little extra bit on. Let's look at one of the questions. 2014 National 5 Maths, paper 1, question 6 had this one. McGregor's Burger sells fast food. The graph shows the relationship between the amount of fat and the number of calories, fat in calories instead of X and Y, in other words. Part A, find the equation of a line of best fit. Well, it's just the same as straight line. We need a point and we need the gradient. So let's find the gradient first. Let's see if we're given any points. Way down, right at the bottom, it says point A represents 5 grams of fat and 200 calories. And point B represents 25 grams of fat and 500 calories. So our 2 points that we've got are 5 and 200 and 25 and 500. So for question A, to get the equation of a line, well, we need the gradient, which remember is y2 minus y1 over x2 minus x1. So x1, y1, x2, y2. That gives me 500 minus 200 on the top, 25 minus 5 on the bottom. Non-calculator, so that gives us 300 over 20. Well, that gives us 15 as our gradient. And we've got a mark there for getting 300 over 20 or 15. Part B, next part of the question, I always use y minus b equals mx minus a, where a and b is a point. So let's just pick the first point, a and b. You could have picked the other one. Subbing that in, you get y minus 200 equals 15, x minus 5. Tidying that up, so it says y equals. You've got a mark there just for getting this, so you get y minus 200 equals 15x minus 75. 5 15s. Y equals, move the 200 across, 15x plus 125. And usually with a straight line question, you'll be done there. But this is worth 3 marks. And you get a final mark for swapping the y and x for the proper terms. So in this question, y is c for calories and x is f for fat. So I switch the y for c equals 15f plus 125 for my final mark. Let's move on to part B. Part B says a super deluxe sandwich contains 40 grams of fat. Use your answer to A to calculate the calories. So we're just substituting 40 in for F. So for part B, F equals 40. So C equals 15 times 40 plus 125. A little bit of work to do. 15 times 40 So 15 times 40, you've got 0, 4 5s is 20, 4 1s is 4, 5, 6. So C equals 600 plus 125, which is 725 calories. And we're done there.
17, paper 1, question 3 says, evaluate 1 5/6 divided by 3/4 and give your answer in its simplest form. So we change the mixed numbers into fractions first. So 1 5/6, 1 times 6 is 6, plus 5 is 11. So that becomes 11 over 6 divided by 3/4. So that becomes 11 over 6. Dividing by a fraction is the same as timesing by its reciprocal. So flip the second one upside down, 4/3. We can now simplify in advance or at the end. So I can divide this one by 2 to get 2, this one by 2 to get 3. And then our final answer becomes 11 times 2 is 22, 3 times 3 is 9. Just double check there's no more simplification. There is not. At this stage I can leave my answer like that. I do not have to change it back to a mixed number, so that's fine. If I did change it back to a mixed number, I would get 2 and 4 9ths. 2017 paper 1 question 4. Very, very similar, so I'll do it the same way. Set my grid up. 2x add 3 on one side, x squared minus 4x add 1 on the other side, times it all together. 2x cubed minus 8x squared plus 2x. And then the bottom, 3x squared minus 12x plus 3. Putting it all together, so our x squared terms becomes minus 5x squared, and our x term becomes minus 10x. So our final answer is 2x cubed minus 5x squared minus 10x and 3.
Being answer 5 maths, 2017 paper 1 question 5 on 3D coordinates. The diagram shows a square-based pyramid placed on top of a cube, and relative to the coordinate axes x, y, z, the height of the pyramid is half the height of the cube. So bear that in mind when we're doing this. And it says A is the point 600. We know that that's the origin, so that's 0, 0, 0. And C is directly above the centre. We have to find the coordinates of B and C. So let's start off with B. So remember how this works. We always start at the origin 0, 0, 0. We think about going along the x, down the y, and up the z if we have to. So looking at this point relative to this point, I don't need to go along here, I'll be out of the way. So for point B, I can immediately start saying 0 for the first number. So I've not moved. I now need to go in here. Well, that distance there, obviously this is a square, remember. So the distance is the same all the way around, that's 6, so that's 6. So I've went in 6. And now once I'm there, I'm on the floor and I need to go all the way up the cube. Well, remember this is a cube, so all the sides are the same, so that's 6 again. So 6, 0, 6, 6 for B. Let's do C, which is a little bit more tricky. So C is kind of in the middle, remember. So if you imagine dropping down there, I need to go along to the middle of this line first, so that I'm in the middle. So that gives me 3 because it's 6 along. Once I'm in that middle, I need to go into the middle again to get to the middle of the square. So I need to go in 3. And then once I'm in that middle of the square, I need to go all the way up the cube and then all the way up the pyramid. So we know the cube is 6 and the height of the pyramid, it says, is half the height of the cube. So that's another 3. That makes 9. So I just write down 9. 3, 3, 9. And we're done there.
2017 paper 1 question 6. The diagram shows a straight line passing through joining the points A and B. Find the equation. So we've given the straight line, we've got 2 points. Find the gradient first. y2 minus y1 over x2 minus x1. So I'll call my first point x1, y1 and my second point x2 and y2. Substituting that in and being careful of the signs, we get minus 2 take away 6 on the top and 3 take away negative 1 on the bottom. So that gives us negative 8 over 4, which is again negative 2. Now use the equation of a straight line. Y minus b equals mx minus a, where a and b is just any point you want. So pick one of the points. I'll pick 3 and minus 2 in this case. So we've got y minus minus 2 equals minus 2x minus 3. Watch your signs. Y plus 2 is minus 2x. take away 6, plus 6. Minus 2 times minus 3 is plus 6. Watch your signs. Then taking the 2 across to the other side, you get y equals minus 2x plus 4, taking away 2 from both sides.
We have a triangle with trigonometry. This is given to you at the start of the exam paper. Just a reminder that it tells you that the area is a half AB sine C. And we're going to look at a bunch of questions that use this idea. So SQA National 5 Maths 2017 paper 1 question 7 had DE is 8, EF is 12 and sine of E is 2/3. Notice this is a non-calculator question, so it's telling you the sine of the angle so that you don't have to work it out already. So the main key point with this is the angle is always in between the two known sides to do the area. So that angle is always our C. So if I want to relabel it, I could call that C, and then that could be A, and that could be B, to give me my little A and my little b here. Well, it's just a substitution. The area is a half of 12 times 8 times the sine of E. Well, C we've called it now, so that would be called sine C. So that gives us 0.5 times 12 times 8 times the sine 2/3. I need to do some work here. 0.5 times 12 is 6. 6 times 8 is 48. So quite quickly we get to 48 times 2/3. And then if you divide 48 by 3, 3 goes into 4 one time. With 1 left over, 3 6 is 18, so that's 16 times 2. So our final answer of 32 square units, which is centimetres. And we're done there.
Linear inequalities. Let's look at some past paper questions. National 5 Maths 2017, paper 1, question 8. Solve algebraic with an inequality, and then it's shown. So these, you just treat these the same as equations, but sometimes you have to change the sign. We'll get to that in a minute if we need to. So we've got 19 plus x is greater than 15. Multiplying it to brackets, we get 3x take away 6. Now, with inequalities, it's always best just to leave your x's over. It doesn't really matter which side, but leave them positive, because if you ever get a negative x, then you have to flip the sign, which you don't want to do. So the smallest x's is on the left, so I'll move them to the right. So I've got 19 is greater than 15. 15 take away 6 is 9. So 9. 3x minus x is 2x. And then we can move the 9 over, so we get 10 is greater than 2x. So dividing through by 2, we get 5 is greater than x. And that is an acceptable answer. But a lot of times your teachers may tell you to change that so that the x is always on the left. If you wanted to do that, then you would just read it backwards. X is less than 5, so the sign changes to less than instead of greater than. But the first answer I gave you is fine as well.
Great, National 5 Maths 2017 paper 1 question 9 had this one, and we have to calculate this angle all the way down here. Now there's lots of ways to do this, but I'll just start from here and work backwards. So these two angles add up to 90 because it's radius meets tangent at right angles. So 90 minus 58 is 68, 78, 88, 32. And now that's an isosceles triangle here. So that is also 32 degrees. And now we can add up with two 32s to make 64. 180 minus 64 to get this one here is 116. So now angles on a straight line add up to 180. So 180 minus 116 gives me 64. And then we're in a new triangle. Isosceles again. So that means I can do 180 minus 64 to get 116 and divide by 2 to get 58. So that means I know that this is 58 and that this is 58 as well. Radius meets tangent at right angles, so these two add up to 90, so that gets me back to 32 down here. I know that these two add up to 180, so I can do 180 minus 58, which is 122. And then finally, 122 plus 32 makes 154. 180 minus 154 is 26 degrees for our final mark. Now obviously there's more than one way you could do this question, but you're getting your marks for 32 here, back down here you're getting a mark for 32, and then a mark for your final answer using standard rules as you go.
2017 paper 1 question 10 said, change the subject of the formula to b. This time was a fraction. So we need to get rid of the fraction, so I'll times both sides by c. So I can just write fc equals t squared plus 4b. And then we're ready to go. We want b on its own, so I'll take away the t squared from the left to get 4b. And I'll divide through by 4 to get fc minus t squared over 4 equals b. Or if you prefer to write it as b equals, then just switch the sides round, but keeping everything in the same order. And we're done.
Squared Answer 5 Maths 2017 paper 1 question 11 on algebraic fractions. Express 3 over a squared minus 2 over a, where a doesn't equal 0, it's just telling you that because you can't divide by 0, as a single fraction in its simplest form. So let's just write this out. 3 over a squared minus 2 over a. So we want a common denominator. Well, a squared is the common denominator because it's bigger than a. So I can make a squared my common denominator. A squared and a squared. So this one's not changed. But this one, to get from a to a squared, I need to times by a. So I'm timesing the bottom by a and the top by a. So I've got 2a on the top. So that gives me 3 minus 2a all over a squared. Try to take out any common factors, there isn't any, so I'm done there. Now, alternatively, just in case you want a quick method that always works, but you'll have to simplify at the end, some people do these ones just by doing 3 minus over a squared over 2 minus a, and to get my common denominator, they always just times the bottom together. So if you do that, you get a cubed. And then you would usually do 3 times a, which is 3a, and minus 2 times a squared. Now, if you did do it that way, which is quite a common way to be taught, you would have to take out a common factor of a at the top to get 3 minus 2a over a cubed. And then you would have to take out, since you're taking out a common factor, you've got a on the top and a on the bottom. So taking it away 1a, you get 3 minus 2a still over a squared, which is exactly the same answer I got before. And now I mean a standard deviation question, this time in the SQA National 5 Maths 2017 paper 1, question 12. So again, a non-calculator one. Gym members are asked to fill in a questionnaire to rate the quality of the service provided. They're asked to rate on a scale of 1 to 6 as shown. 5 gym members picked 1, 4, 6, 3, 6. And its simplest form of standard deviation can be written as a root b over 2, calculate the values of a and b. Do not be worried that we've done that. That means that we're just combining this with surds. But your step, it's mentioned standard deviation, so again, you're going to calculate standard deviation. So step 1 is to draw my table, but I get the formula from the start of the exam paper first. The sum of x minus x bar squared over n minus 1. That's a little bit messy. But our table, if you recall, is always the same. X minus x bar, and x minus x bar again, squared, all from the top. And we can write down our numbers, 1, 4, 6, 3, 6. 1, 4, 6, 3, and 6. We add them up at the bottom. So being very careful, 6, 7, 8, 9, 15, 19, 20. So our total is 20, which means our mean is 20 divided by 5, which is 4. In the middle, we take away our mean then. So 1 minus 4 minus 3, 4 minus 4 is 0, 6 minus 4 is 2, 3 minus 4 is minus 1, 6 minus 4 is 2 again. And then the last column was square. So that gives me 3 3s is 9, 0 0s is 0, 2 2s is 4, 1 1s is 1, 2 2s is 4. And then we add them all up. 9, 13, 14, 18. There's our key number there. Already we've got a mark for calculating the mean, a mark for getting x minus x bar, and then we get another mark for substituting that into our standard deviation, which is the square root of 18 over 4. One more mark left just for using surds. So we have to leave it in the form a root b over 2. So we need to simplify this in some way. So we can separate that into two square roots, square root of 18 over the square root of 4. I need two numbers at times together to make 18, one of them a square number, so that's 9 times 2, and the square root of 4 is 2, so that leaves a final answer. Square root of 9 is 3, root 2 I can't do anything with, all over 2, our final mark, 3 root 2 over 2. Refer back to my surds in the numeracy unit to get more work on surds.
Okay, National 5 Maths 2017, paper 1, question 13 was a picture, but it gave you the two equations as well. It says the graph shows two straight lines with these equations. The lines intersect at point P. Find algebraic the coordinates of point P. If it mentions point of intersection, that means solving simultaneous equations. That's a key thing to realise. So I just need to solve both of these equations simultaneously. So if I look at my two equations, I've got 3x minus y and x plus 3y. So I could times one of these by 3 to make the x's the same, or times this one by 3 to make the y's the same. This time I'm going to make the y's the same. So just times in this one by 3. I can write down the new equations I get. So the first one I'm going to get is 9x minus 3y equals 6. So I can write that, 9x minus 3y equals 6. And the second equation is staying the same, x plus 3y equals 19. So I'll call that equation 1 and equation 2. And this time you can see that these numbers are the same, but they're different signs. So I add the equations when they're different signs. So I do 1 plus 2. So 9x plus 1x is 10x. The y's disappear. 19 plus 6 is 25. So x is 25 over 10. Leave that as a simplified fraction if you want, or a decimal, because it's an easy decimal. I would write 2.5 for this one. Okay, and then we need to substitute in to get our y. So just pick a simple equation. I'm just going to pick x plus 3y equals 19, because there's only one x there. So I've got 2.5 plus 3y equals 19. So 3y equals 19 minus 2 is 17, minus 0.5 is 16.5. And just checking, this was a paper 1 question, yep. So I need to divide through by 3. Three fives are 15, leaving 1. 3 5s are 15 again, 5.5. So we've now got our two numbers, 2.5 and 5.5, but it's to find the point, the coordinates of P. So I need to change that to a coordinate, an x and a y. So our final answer is 2.5 and 5.5. And we're done there. Like the square of parabolas, SQA National 5 Maths 2017, paper 1, question 14. The graph shows a parabola with the equation of the form x plus a squared plus b. That's called completing the square, remember. The equation of the axis of the symmetry of the parabola is x equals minus 5, as shown. State the value of a. So this is testing. Do you know that this tells you that? It does. It tells you the turning point. The a is the 5. So all we're asking you to do is write a equals 5, not minus 5. Because it's what makes this bracket 0. So it's 5 here. So it's minus 5 plus 5 is 0. So it's just 5. So a equals 5. It now says the point 3 minus 8 lies on the parabola. Calculate the value of b. So we've got x now equals, y equals, sorry, x plus 5 squared plus some number b. But we know the point lies on, so we're going to substitute the point in because that's an x value and that's a y value. So a is our y equals minus 3 is our x plus 5 squared plus b. So a equals minus 3 plus 5 is 2 squared plus b. 2 squared is 4 plus b. It should be clear that b must then equal 4 because 4 plus 4 is 8. If it now asked us what the turning point was, we would also know the turning point, it would be 5, 4, because that's exactly what completing the square does. SQE National 5 Maths 2017, paper 1, question 15 on similarity. In the diagram below, TS is parallel to QR, TS is 5, QR is 7, SR is 2.6. Find the length of PS is X, calculate length of X. So this is similarity because we've got parallel lines and making triangles. So we've got one big triangle and one little triangle. So I can draw them out separately to illustrate this. For the small triangle, that goes like this. I'll put the little arrow on it. That's 5 by X. And then for the big triangle, we'll just draw it a little bit bigger so you can see, that is 7. And usually, and then the bottom length is X plus 2.6. So if we think of our linear scale factor, if we just think of a big triangle to little triangle, the large scale factor, it's 7 over 5. Same side over same side. But it's also this side over that side. So I can see that that equals X plus 2.6 over X. I've now got an algebraic equation to solve, so I'll just go ahead and solve it. And with two fractions, you can just do top times bottom. 7x equals top times bottom, so I'll just put brackets around that. 5x plus 2.6. Expanding my brackets, 7x equals 5x. 5 2s are 10, 5 6s are 13, so that's plus 13. That means that 2x equals 13, so that x is equal to 6.5 centimetres. And the question was, find the value of x. That's me done. Happy days.